Good morning, friends. Today our topic is phenols. These phenols are also known as hydroxybenzene. Hydroxybenzene. Now, this phenol is also known as phenyl hydroxide. Phenyl hydroxide. Then these phenols have two more names, and in that one is the benzenol, whereas the another name of the phenol is the carbonic acid. So here from the headline it indicates that the phenol is very important organic compound, and these phenols are various names according to their structures or according to their uses. Now see here that why these phenols are also known as these names. First of all, this we will discuss here, and then later on we will discuss what is meant by phenol. Now the phenol has the structural formula is like this: aromatic ring, and on this aromatic benzene ring here the OH hydroxyl group is present. Okay. Now here as we see here that the structure here this OH group is a hydroxy group, and this OH group is present on the benzene ring. Therefore, phenols are also known as the hydroxybenzene. Okay. Now, after this, that we come to that the next name, that is the phenyl hydroxide. Now, actually, in this aromatic ring, there is a C6H5 group, and this C6H5 group is known as the phenyl group here. And on this C6H5 here, the OH group is present here. That's why it is known as the phenyl hydroxide here. Means it is a C6H5OH. Okay. Whereas the phenols, another name is the benzenol. Now here, as the phenol contains the benzene ring, therefore the word is the benz here. Okay. And on the benzene ring here, OH hydroxy group is present, and here due to this OH group here, the OL suffix is here is in the name, and therefore the name is the benzenol here. Understood? Now one more name remains, that is the carbonic acid. Now in your exam in board as well as in the MCQs, means that the CET or the NEET exams, that the question may arise on this, that the sentence phenols are also known as the dash. Then in that answer that there should be one option, and that should be the carbonic acid. Now the question arises that why phenols are also known as the carbonic acid. Now as we know that the phenols, that the reactions, that the phenol while reacting at the phenols, that phenol gives that the H plus ions here, or it donates the H plus ions. Okay. And to form the phenoxide ion here, and this donation of the H plus ion indicates that the phenols are acidic in nature. Okay. Therefore, phenols are also known as the carbonic acid. Or in another sentence also, that the phenol contains near about like 5% water. Therefore, that phenol is acidic in nature, and therefore also the phenol is also known as the carbonic acid. Okay. So this is the reason why phenols are also known as the carbonic acid. Now I would like to tell one more sentence about that the phenol. Phenol was discovered by the scientist, and the name of the scientist, that is the Runge, in 1834, and he prepared phenol from the coal tar distillation. Means he taken that coal tar and that coal tar's distillation have done by the that range and he prepared the phenols. Okay, so in the MCQ also that the question may ask like this here: phenol was discovered by that dash, and in that one of the option that is the range. Actually, the 1834 is not important. Okay, now after this that the introduction of that these phenols and their names. Now come toward that the actual what is meant by the phenols. Now here I will tell you that the two different terms of the phenols here. Now in that the first one that is the phenols are the aromatic hydroxy compounds in which one or more hydrogen atom is replaced by the OH group. Okay, it is the definition of that is the phenols. Now in this definition what I have told here that the phenols are the aromatic hydroxy compounds. Now as I have written the structure of the phenols, they clearly indicate that the phenols are the aromatic hydroxy compounds. Okay, means here that the aromatic hydroxy word is important here, and as the aromatic word is used here that when we say that the aromatic compound, then aromatic compound contains at least the one benzene ring here, or the famous example of that the aromatic compound is that is the benzene ring here. Therefore the phenols are the aromatic compounds. Okay, and in which now how the phenols are formed that I have explained in this term here. Phenols, the phenols are the aromatic hydroxy compounds and in which one or more hydrogen atoms are replaced by the OH hydroxy group here. Means for example here that suppose that is the this should be the benzene here. Okay, means it is the aromatic compound. As we replace here that the one hydrogen atom from this benzene ring here, and when I kept here that the OH group, then it is known as the phenol. Okay, now as we remove here that the two hydrogen atoms from this benzene ring, and when I kept here that again that the OH group, then it is also that is the phenol. Okay, so in this way here we get phenols here. Means by replacing hydrogen atoms from the aromatic ring, and if we keep the OH groups in that aromatic ring, the phenols that we will obtain. Okay, so in this way here that this is the one term of that is the phenols. Now these phenols are also termed in another way also, and it is like this here, where one or more means more than one, means 2, 3, 4 like that, where one or more hydroxyl OH groups are directly attached to the aromatic ring are also called the phenols. Okay, actually that the meaning of this term is also same one to the first one. Okay, but way to express is somewhat different one. Okay, so once again I will repeat that the same term, but I told here that when one or more hydroxyl OH groups are directly attached to the aromatic ring. Means when we say that the phenols, in phenols always that the OH group is directly attached to the aromatic ring or the benzene ring. But you remember that here already we have learned alcohols, and in the alcohols the OH group is also present here. In alcohols and the phenols that the OH hydroxy group is the same one, but there should be difference between the alcohols and the phenols. In alcohols the hydroxyl OH group gets directly bonded to the aliphatic carbon atom. Okay, and the representation of the alcohol is the ROH. For example, that is the CH3OH methyl alcohol or the C2H5 methyl alcohol. So this should be the difference between the alcohols and the phenols, and as well as it is the another term. Means again I would like to hear that the explain in one sentence that in alcohols that hydroxyl OH group gets directly bonded to the aliphatic carbon atom, whereas in the phenols the OH group gets directly bonded to the here aromatic ring. Okay. Now after this, that the terms of the phenols comes toward that representation of that is the phenols here. Just like that the alcohols are represented by the ROH, like that the phenols are represented by the AROH here. Now what is meant by the AR? AR means the aromatic ring. Means from this structure it is clearly indicate that AR is the aromatic ring, and on the aromatic ring here that the OH group is present here. Okay, so it is the representation of that is the phenol. Okay, so in this way we have discussed that the introductory part of the phenol as well as that is the term or the definition of that is the phenol. In both actually that the question may ask for the 1 mark, what are phenols? That time you have to write down that these terms here, out of these two you can write any one term. Okay, now after this that the definitions that come toward that, the next article of the phenol, and it is the classification. Now classification of the phenols. Phenols are classified into 3 types, and which are that 3 types? First is the monohydric phenols, second is the dihydric phenol, and third is the trihydric phenol. Okay, now we will discuss one by one here. First of all, monohydric phenol. Monohydric phenol. Now the name it indicates that mono means single and hydric word is used for the hydroxy OH group. Okay, and as it is a phenol here, means here it indicates that the phenol contains only one OH group here, and the representation of the phenol is like this. Already you know, or this is the example of the monohydric phenol also. It is a permanent phenol or it is a monohydric phenol. Okay. Now here along with this here that there are lots of examples of the monohydric phenol. In that one is the OH here and CH3 here. Then next one is the aromatic ring, and on this here again that the OH and CH3 groups are present here. Then the next one example is like this here, benzene ring, OH and the CH3 group here. Okay. Now the next example is like this here, OH, NO2, then OH, NO2, OH, NO2, and one more example here, OH and the Br here. Okay, now see here that all these are the examples of the monohydric phenols. Okay, now if we observe that all these structures, then all these structures contains that only one hydroxyl OH group on the aromatic ring. That's why all these are the structures of the monohydric phenol. Okay, now see here, this structure contains only one OH group, this structure, this structure, this structure, this structure, or all these structures also. Okay, so all these structures contains only one OH group, and therefore it is known as the monohydric phenol. Okay, as already I have told you that mono means the single, and which part is present on the aromatic ring, hydric is the OH group is present. Okay, therefore all these are the monohydric phenols. Now come toward that the definition. Now the definition is very simple and very clear. In one sentence, I would like to tell here that it contains only one OH group. Yes. Once again, I will repeat. It contains only one OH group, are called the monohydric phenol. Understood? Now, here the question may arise in your mind that why I have written that all these structures or only that the monohydric phenol. Actually, behind that there is a logic, because in that the same article in classification of the phenols, I would like to tell here that the nomenclature of these phenols also. That's why I have written all these examples on the here that the board here. Okay, but later on we will discuss here that the nomenclature of all these structures here. But before going to that here that we will discuss that the second type of the here phenol, and it is the dihydric phenol here. Okay, dihydric phenol. Now, here the term indicates that di means two, and which groups are present for the 2-hydric OH groups. Okay, and on the aromatic ring is on the benzene ring here, and the examples are here OH, here OH. Okay, then the next one example is the benzene ring. On the benzene ring here OH groups are. Then next example is like this here, OH and OH. Okay. Now the definition of the dihydric phenol is very simple. It contains 2 hydroxyl OH groups. Okay, understood? Simple meaning of the dihydric phenol. And don't go that the last one term, it is the trihydric phenol. Trihydric phenol. Now, as the name indicates that it contains how many OH groups on the benzene ring? Yes, it contains 3 OH groups on the benzene ring. Benzene ring, and on the benzene ring here that OH and OH is present here. Okay, then next example is like this here, OH and OH here, and one more structure I will write here, benzene ring. On the benzene ring here 3 OH groups are present. Okay, now here, as we see here that all these 3 structures, that these 3 structures contains that 3 hydroxyl OH groups on the aromatic ring, 1, 2, 3. Okay, that's why it is the trihydric phenol. This structure also contains 1, 2, 3 OH groups on the aromatic ring. Therefore, it is also trihydric phenol. And the last structure also contains 3 OH groups. Okay, therefore all these are the trihydric phenols. Okay, and the term is like this here. It contains 3 OH groups. Finish. Okay, so in this way we have discussed that the classification of that is the phenols.